Okay, in this video, I'm going to show you another way you can summarize data. And the third way you can summarize data is called measures of position. In this course, we're going to go over three measures of position. The first one is called z-scores. And what is the z-score? How far is the data value from the mean? In other words, how far are each of these numbers that I have in my data set? I have 17 test scores. How far away are each of these from the mean? Now remember, in this bell-shaped curve, the middle is the mean. And my mean is 74. That's what you can see right there. Okay, and we got all of the other numbers to the right and to the left of the mean using the standard deviation. My standard deviation was 9, so I got 83 by counting by 9 more to the right of 74. The 92 and the 101 I obtained it the same way. I kept counting by 9 from 74. Same thing what happens to the left of 74. All of these numbers, we got it by counting by 9 to the left. Okay, so what I want to do is I want to find out how far away are each of these numbers, 83, 92, 101, 65, 56, and 47. How far away are those numbers from the middle, which is the mean? And the way I'm going to find how far away are each of those numbers is asking myself, how many times I counted by 9? How many times I counted by the standard deviation? So what I'm going to do is I'm going to draw a new bell-shaped curve. In fact, it's a copy paste of this same curve you see on the screen. There it is. Okay. However, the marks on the number line, I didn't put the same numbers that I had before. I'm going to put new numbers. And the new numbers are going to be the z-scores. That's why this number line, I'm not going to call it X like before. Instead, I'm going to call it Z. X is when you're working with the actual value from the data set. Okay, so these are actual test scores. What I'm going to write next are not actual data values, okay, actual test scores. What I'm going to do is I'm going to write here new numbers that is based on how far away is the data, each of these numbers, from the middle. So if I ask you how far away is 74 from 74, your answer will be 0. Because 74, how far away is the 74 from itself? Nothing. Okay. Now, if I ask you how far away is 83 from 74, well, how did I get that 83? Well, I counted by 9. I added 1 9 to the 74, and that's how I get the 83, because the 9 was the standard deviation. So how many 9s I use? 1. So 83 will be the first mark to the right of the 0, and I'm going to put 1. Why 1? Because I only use 1 9. I only use one standard deviation. Okay, and I'm going to ask you the same question again. How did I get the 92? How many 9s, how many standard deviation you use from 74 to get to 92? So if you see what I'm drawing here, these arcs, I use 2 9s from 74. 9 more from 74 is 83. 9 more from 83 is 92. So I use 2 standard deviation. So 92 is the second mark to the right of the middle. So this mark, I'm going to put 2. And what does that 2 is saying? That 92 is 2 9s away from 74, the middle. Same thing I'm going to do with a 101. Okay, how many 9s did I use from 74? You use 3 9s. That's why I put 3 here. Okay, so let's recap. How did I get this 0? I asked myself, how many 9s I used to get to 74 from 74? Or put it this way, how far is 74 from itself? 0. How did I get the 1? Because 83 is 1 9 away, 1 standard deviation from 74. How did I get the 92? 2 9s, 2 standard deviation from 74. 101, 3 9s from 74, the middle. Okay, now I'm going to do the same thing to the left. Okay, same idea. So how many 9s I use to get to 65 from 74? I use 1 9. However, I'm not going to write positive 1 to the left of 0 here. 65 is the first mark to the left of the middle. So this mark is the first mark to the left of the 0. I'm not going to put 1. Instead, I'm going to put -1. Why -1? Because I'm counting to the left. But it's still 1 9. Okay. I'm going to do the same thing with 56. How many 9s did you use to get to 56 from 74? I used 2 9s. 56 is the second mark to the left, so this will be -2. Okay. And 47, how many 9s did I use from 74 to get to 47? I used 3 9s. And again, why negative? Because I'm counting to the left. Okay, and this is what we call the z-score line. Okay, and each of these numbers has a z-score of that you see on the number line. So if I ask you, what is the z-score for 83? The z-score is 1. If I ask you, what is the z-score for 56? Then based on the number line that I did down here, label Z, that will be -2, because 56, I used 2 9s to the left from 74 to get there. If I ask you, what is the z-score for 74? Okay, how many 9s I used to get 74 from 74? I use none. Okay, that's the 0 you see right there in the middle. So this number line here is really counting standard deviation. So how many standard deviation you use to get to 74 from 74? None, 0. How many standard deviation you use to get to 83 from 74? 1 standard deviation. 92, 2 standard deviation. 101, 3 standard deviation. The 65, -1 standard deviation. And just keep in mind, the negative means I'm counting to the left. 56, -2 standard deviation. 47, -3 standard deviation. And who's really the 0? The mean. And this is what we call a z-score. In the next video, I'm going to show you how do you find the z-score of values that you do not see in this line. Okay.